Chapter 1, Exercise 20. 1. Cuts. Let us recall the first two properties of a cut. Alpha is a subset of Q. 1. Alpha is not the empty set, and alpha is not Q. 2. If P is an element of alpha, and Q is an element of Q, such that Q is less than P, then Q is in alpha. For Q in Q, the sets alpha sub Q equals P element of Q, where P is less than or equal to Q, satisfies this new definition of cut. That means that new R star is not empty. 2. Ordered set. Define alpha, this symbol, beta, to mean alpha is a proper subset of beta. Now we check that this meets the requirements of definition 1.5. If alpha is a proper subset of beta, and beta is a proper subset of gamma, note that alpha is a proper subset of gamma, since a proper subset of a proper subset is a proper subset. Note that at most one of the three relations, alpha proper subset of beta, alpha equals beta, beta is a proper subset of alpha, can hold for any pair alpha beta. To show that at least one holds, assume that the first two fail. Then alpha is not a subset of beta. Hence, there is P in alpha with P not in beta. If Q is in beta, it follows that Q is less than P by 2, since P is not in beta, and thus Q is in alpha, again by 2. Therefore, beta is a subset of alpha. Since alpha does not equal beta, we conclude beta is a proper subset of alpha. Thus, R star is now an ordered set. 3. Least upper bound property. We claim that the ordered set R star has the least upper bound property. To prove this, let A be a non-empty subset of R star and assume that beta in R star is an upper bound of A. Define gamma to be the union of all alpha in A. Thus, P is in gamma if and only if P is in alpha for some alpha in A. We shall show that gamma is an element of R star and that gamma is supremum of A. Since A is not empty, there exists alpha in A. This alpha is non-empty. Since alpha is a subset of gamma, gamma is non-empty. Next, gamma is a subset of beta because alpha is a subset of beta for every alpha in A, and therefore gamma is not Q. Thus, gamma satisfies property 1. To prove 2, let P be in gamma. Then P is an element of alpha for some alpha in A. If Q is less than P, Q element of Q, then Q is an alpha, and thus Q is an element of gamma. This proves 2. Therefore, gamma is a cut, that is, gamma is an element of R star. Note that by definition of gamma, we have alpha proper subset or equal to gamma for every alpha in A. Suppose delta is proper subset of gamma. Then there is S in gamma such that S is not in delta. Hence, S is in alpha for some alpha in A, and so delta is not an upper bound of A. Thus gamma is supremum of A. Therefore, R star has the least upper bound property. 4. Axioms for addition. We have the definition of addition of cuts. If alpha beta is an R star, then alpha plus beta equals set of R plus S, R element of alpha, S element of beta. We define 0 star equals set of P and Q such that P is less than or equal to 0. Note that 0 star satisfies 1 and 2, but it has the maximum element 0. Note that the addition so defined satisfies axioms A1 to A4. Indeed, A1. We have to show that alpha plus beta is a cut. Note that alpha plus beta is a non-empty subset of Q. Take R prime, not an element of alpha, S prime, not an element of beta. then r prime plus s prime greater than r plus s for choices of r in alpha, s in beta. Thus, r prime plus s prime not an element of alpha plus beta. It follows that alpha plus beta has property 1. Let P in alpha plus beta, then P equals r plus s with r element of alpha, s element of beta. If Q less than P, then Q minus s less than r. So Q minus s element of alpha, and Q equals Q minus s plus s element of alpha plus beta, thus 2 holds. A2. Using the commutative property of addition in Q, we have alpha plus beta equals set of r plus s such that r is in alpha, s is in beta, equals set of s plus r such that r element of alpha, s element of beta, equals beta plus alpha. A3. As above, this follows from the associative law in Q. A4. Let alpha element of real numbers. If r is an alpha and s is an element of 0 star, then either r plus s less than r or r plus s equals r, which implies that r plus s element of alpha, that is, alpha plus 0 star subset of alpha. For any p in alpha, we always have p plus 0 equals p, so that p element of alpha plus 0 star, that is, alpha subset of alpha plus 0 star. Hence we have alpha equals alpha plus 0 star, and the addition satisfies A4. Not A5. Now we show that the ordered set R star does not satisfy A5. Let alpha be the set P in Q such that P is less than 0, element of R star. Assume that there was beta in R star such that alpha plus beta equals 0 star. Since 0 is an element of 0 star, then there exists P in alpha and Q in beta such that P plus Q equals 0. Since alpha has no largest member, then there exists R in alpha with P less than R. Now, R plus Q element of alpha plus beta equals 0 star, but R plus Q is greater than P plus Q equals 0. This is a contradiction because 0 is the largest element of 0 star. Hence, the addition does not satisfy A5. With this exercise, it is illustrated that to condition 3 in the definition of the cuts is necessary to be able to build the ordered field R. In the definition of cuts in Rudin's book, the rational number R is identified with the cut P element of Q such that P is less than R, equivalently with the supremum of the cut P is in Q such that P is less than R. When condition 3 is deleted, we have a problem to assign a cut to the rational number R because R equals supremum of P element of Q such that P is less than R equals supremum of P element of Q such that P is less than or equal to R. Thanks for watching.